All right, so example 4, continuing on with this idea of tangents. You can see here that we've got this circle drawn with zy and zx drawn to the circle at right angles to the radii, ty and tx. So since this segment zy is perpendicular to that radius ty, that tells me that zy is tangent to the circle at y. And since zx is perpendicular to tx, the radius, this segment zx is tangent to the circle t at point x. So we have two tangents drawn to the same circle from the same exterior point from the circle, which is point z. What they want us to determine is what is true about yz and xz. Okay, so the two tangents drawn to the same circle, I want to come up with a relationship here. And the first thing I'm going to do is I'm going to draw a segment from z to t to create triangles. Right. Anytime I see right angles, I like to see right triangles. So just a common practice here, when you see right angles and you don't have triangles to start off with, if you create right triangles, you get a lot of properties that come into play. Specifically for right triangles, there are congruence properties that we learned back in chapter 5 maybe. Hypotenuse, angle, hypotenuse, leg, 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 and leg angle. Those are 4 specialized properties of congruence for right triangles. The reason I'm going towards congruence is because radii are of equal length, right? So the two radii, ty and tx, have the same length. The segment I just drew, tz, which is shared by both right triangles, is equal to itself. So a lot of congruence is going on here, so I'm kind of thinking towards congruence. So if I start marking what I know, obviously the right angles have been marked for me. I know ty and tx are both radii to the same circle, therefore they're congruent. And zt, this segment here, is congruent to itself. And looking at this picture, ty is a leg, tx is a leg. Tz is a hypotenuse for both triangles because there's opposite the right angles in both. So we have hypotenuse and leg of two triangles congruent to one another, so the two triangles are congruent triangles. So I know for a fact that triangle, I'm going to call it tyz, must be congruent to triangle something. All right, so we have to label things in the same order. So I know y and x are both the right angles, so I'm going to put x in the middle. I know ty matches tx, so ty is in front, so I'm going to put tx in front. I know tz matches tz, so tz first and last, tz first and last. So there's my congruent statement written in the proper order. And once I get the congruent statement, I can therefore then lead to whatever I need to lead to. And I'm not writing a proof here, but the reason why is, of course, hypotenuse leg. And then they want a relationship between yz and xz. Well, taking a look, yz and xz are in the same positions in the congruent statement, therefore they should be congruent to one another. So I know that yz and xz are congruent. Yz is congruent to xz by cpctc. I haven't seen that one in a while, right? But again, we had congruent triangles back a while ago, and these theorems came up, and again, quite often in these congruence of triangles theorems, once we proved triangles congruent, we led on to then say the corresponding parts were congruent. Okay. I also know that angle T matches angle T, so that means that this angle here should be congruent to that angle there. This angle here should be congruent to that angle there. So we can also say if we have two tangents drawn to the same circle, first of all, the two tangents must be the same length. All right, so that's what this proves. So if there's some point outside a circle, I draw a tangent on one side, I draw a tangent on the other side. Those two tangents are going to be congruent to one another. The other thing I can say without a doubt is if I were to draw the segment from that point to the center of the circle, if I draw that segment in, that segment is going to bisect the angle up here and the angle down there every single time. So again, that just leads us to a few properties about circles with tangents that we might be able to use to write a proof or possibly to solve a problem involving circles and tangents. So keep those properties in mind as we go forward.